Hey, Liberty North AP Psych testers. Good afternoon. It is Tuesday, April 28th. This is exam prep session number 2. Okay. All right. So let's go. Okay. You guys got this. Today, we're actually going to go over information for question 2. All right. So we're going to start. We did some general information yesterday, and today I want to start with number 2 just so we can get it out of the way because it's very specific. So we can kind of just talk about it and then give you the information that you need to kind of prep for that. Okay. So question number 2 is going to be 15 minutes, right? Okay. It is over research methods specifically, and it's 45% of your grade. First of all, realize in the prep part of this that 15 minutes is not very long, and you're probably going to need most of that to write. Make sure, since it is open notes and stuff like that, again, the first 2 chapters on your AP notebook, students, should be chapter 1 and 2, which is perfect because chapter 1 is definitely a question, and chapter 2, which we'll talk about tomorrow, will most likely be incorporated in question 1. Okay, so make sure you have easy, quick access to chapter 1 notes and information because you're not going to have time to look up a lot of different information. You're going to need to start writing almost immediately on question 2. Okay. All right. So you need to read and review chapter 1, research methods, in our textbook. Okay. You also need to read and review your journal critique. Okay. Is why we use that. That's why we do that assignment. One of the reasons, teach you APA and then to get you prepared for the AP test and what it's like to critique, analyze, and interpret research. Okay. And then make sure you have chapter 1 in your AP notebook, with your learning targets and your vocab. Make sure you have that available and ready to go, okay, for the test. All right. So the question is going to be that they're going to give you some type of research. They're going to summarize some type of research method, and they're going to give you data in a chart. Okay. That's what they're going to do. And so what they're going to ask you to do is analyze the research and interpret the data. Okay. So what conclusions can be drawn from this research? Is what they're going to do. Now they're going to give you 6 specific tasks. So once they summarize, they're going to give you a general overview of the research, okay, that was done. They're going to give you a chart with the data, okay, and most likely the chart are going to be found in chapter 1. So it's going to be a scatter plot. It'll be a standard deviation. It'll be a correlation coefficient. They're going to give you one of the data points or data summary points that we went over in chapter 1. Okay. And then they're going to give you six tasks with that information. So one of them is generally always, what conclusions can you be drawn? Was the research, in your opinion, done well? What were the results based on the data given? Something along those lines. Okay. So basically, in small summary, you're going to be critiquing the research. Okay. And the results. Okay. All right. So you should be ready for this. You're prepared for this. Okay, you've got this one. All right. So now key terms from chapter number 1 that you need to know. Okay. So make sure, and again, I'll send a picture of this on Twitter, but these are all from chapter number 1, except for chapter number 18 stuff. Okay. So, chapter 18 actually has a lot of group behavior influences that can be used in this question. Your confirmation bias for stuff that confirms my opinion. You've got in-group, out-group, researchers. There's just a bunch of group dynamics in that environment that you could also throw in here as well. Okay, but you definitely need to know. So the first 3 terms, again, are my 3 big obstacles to scientific thinking, right? So we went over this. So hindsight bias. If I'm biased in any way, shape, or form, okay, basically any type of bias, okay, can influence my results and my research method, okay, whether it's confirmation, hindsight, whatever. Generalization, again, we talked about that. And that's a big one that you're going to be able to use, but in research today, somebody does one study and then boom, the results are out there, and we generalize them and we accept them. And that's not how science is supposed to be done, right? Replication. Nothing should be said. Those results shouldn't be generalized to anything or anywhere. We need to make sure that the study is replicated multiple times and that they're getting the same results, right? Because if just somebody does one other study and it contradicts those results, we've got an issue, right? Which could happen very easily. So remember, that's a big one for the scientific method. And we don't, as an American culture, we don't do that very well. So, all over the news, they just grab one study at one place and then they summarize the results. One study found, one study found. Okay, one study should never find anything. That's the starting point for the scientific method, right? And then we replicate, reproduce. And if we're getting the same results, then we've got some. Then we can announce it, okay? And then overconfidence, okay? Which can also lead to bias, because if I think something makes sense, that something's going to happen, then I've got bias, right? Okay. But my overconfidence in my method, my scientific team, my research, my topic, my hypothesis, all of that could lead to overlooking something and hurting the scientific method. Okay. So first part that you're probably going to need is, obstacles, just general obstacles to scientific method, to research methods. Okay. Having sound science and research. Okay. Then the other ones are basically research questions, which all of this you do in our journal critiques. Okay. So research methods. So make sure you know the different research methods. Okay. So we have 6, including the test. Make sure you know the difference between qualitative and quantitative, right? Okay, that's big. You have to critique it, and they're going to use this language in your question, all right? So qualitative is descriptive, okay? It's descriptive. It's not an experiment. There is no control group, okay? Therefore, it does not cause an effect. It's only, I can describe a relationship that exists, okay? So if I want to study the impacts of caffeine on sleep, okay, I can do a survey, I can do a test, I can do a correlation, I can do a case study, but all that is just going to tell me that sleep and caffeine are related, right? Okay, that's qualitative data. It just describes a relationship. Quantitative data is cause and effect, okay? And the only thing that shows cause and effect in psychology is an experiment, okay? Something that has a control group, a placebo group. That's what we have to have. Okay. So the only thing that is quantitative, remember, is an experiment. That's it. That's the only thing that shows cause and effect, because we're researching people. Okay. That's another big difference in psychology. Don't forget that we're researching people. So we're different than any other science. We've got more restrictions, more legalities, more constraints on us, because we can't treat people like a variable or like an element or something like that in a lab. Okay. So if I want to do an experiment, then on how caffeine impacts sleep, then obviously I'm going to need to have a control group in there. So I'm going to have a group that drinks caffeine and a group that doesn't, right? And then I'm going to compare their results. Okay, that's quantitative. That's cause and effect. So at the end of that, I could say caffeine causes an impact on sleep, okay? Not that they're just related, but that it causes an impact on sleep, okay? Cause and effect, okay? And again, you had to answer that in your journal critique, okay? And then internal and external validity, okay? That's a big one, okay? So, and those were 2 sections on your journal critique that you had to write about. Internal validity is and this is the one that most of you struggled with, that's the internal process, okay? How was the research done? Was it done well? Was it operationally defined? Did they use materials, measures that have been used before that are valid, okay? So this is the internal, the method, how they did the research. And external then is who can the results apply to, okay? We want it to be able to apply as many people as possible. We don't like research to be so small, and that's another thing that we do in generalization. They might be quoting a study that was done on 3 people or 2 people or 20 people, and that shouldn't even be summarized out there. It's just a starting point, because it applied to very many people. Okay, we want it externally to be able to go and apply to as many people as possible. Okay, the more we can apply it to, the better. Okay, so internal validity is the actual method. Was the method done well? And external validity is who can I apply this to based on my subjects. Remember, it's based on my subject population. Okay, all right. Okay, and then also, again, remember the definition between reliability and validity. Reliability is replication with same results, okay? If the results are reliable, then I'm going to get the same results each time. Okay. Now to test reliability, I need to be able to replicate. Okay. So again, replication was a huge term for chapter 1 in our book. It's kind of, some people say it's the key to experimental science. All right. You have to be able to reproduce, and then you want to have the same results. Okay. That's reliability. Validity is, am I measuring what I'm measuring, what I'm wanting to measure? And it makes sense. Am I measuring what I'm supposed to be measuring? So if I'm doing a study on intelligence, am I actually measuring intelligence? Okay. And that's where on the internal validity, you get your measures. You know, what tools did you use? Like if we're doing sleep and caffeine, you know, how did I measure my impact on sleep and my caffeine consumption? You know, what tools did I use to measure those things? And were they used before? Did other previous studies use them? Because then they're more likely to be valid, right? But I have to use some type of inventory that really measures impacts on sleep, right? I've got to use a good tool for that, okay? And that would be validity, all right? If I'm measuring intelligence tests, what did I use to measure intelligence test or intelligence? I've got to use something that I've used in the past that has been shown to be valid, okay, proven to be valid, that it actually measures intelligence or aspects of intelligence, okay? All right, standardization, okay, all good research has standardization process, meaning that generally, you know, we're going to test it on different people, okay? And this kind of goes back to the replication part of it, all right? So, you know, we talk about this personality, intelligence were big ones. You know, if I develop an intelligence test or a personality test, I need to test it on people. Okay. If I develop an experimental method, I need to standardize. I need to do it on several groups, right? To make sure that the method's good, to practice it on a group, and then I'll do it. Okay. Once I think I've got it all refined, then I'm going to start doing it and really tallying for the results. Okay. Random selection and random assignment. Okay. We had some people struggle with the difference between these. Okay, so remember your Skittles assignment. Okay, remember the Skittles lab that we did way back at the beginning. Random selection is, how do I select the students for my research? Okay, what's the process involved for me getting my research subjects? Okay, that needs to be as random as possible. All right, so that way I can then apply my results to more people, right? Okay, so random selection. Okay, random assignment, again, is if then I have different groups in my research, how are those subjects who are randomly picked then randomly divided into groups, okay? So if I did caffeine and sleep, I'm gonna have a caffeine group and a non-caffeine group, right? Or I might have 3. I might have a soda group, a coffee group, a tea group, and a water group, okay? How am I gonna divide my randomly selected and chosen subjects into those 4 groups, okay? I need to be able to just randomly place them, randomly divide them into the groups, okay? So that's the difference. So make sure you look up that and focus on that, okay? So use your journal critique. The book talks about random selection. I don't think it mentions random assignment. So make sure you know the difference, okay? And then operationally defining terms, okay? So again, in order for me to reproduce, I have to make sure that the study is operationally defined. So if I'm using and following good science, I'm going to lay out and define all aspects of my research because I want somebody else to replicate it, right? I want other scientists to reproduce it because it's kind of like in science, we're all in this together. It's kind of like a teamwork framework, but I need other people to try to do my study again so that they can confirm my results, right? Which would then show me reliability, okay? All right, so I want other people to reproduce my research. So I need to make sure that I do the research, summarize the research, write the research in a way where people can follow it and reproduce it and replicate it if they want to, okay? All right, so we talked about the Mozart effect. So you remember, so one of the good things that original first study did is it did lay out and it was done and operationally defined really well. So that then there were countless replications of it. Now, they found out that the original one was not reliable because nobody was reproducing the same results, okay? But that's still science. That's how it's supposed to work. Now, unfortunately, so a billion-dollar industry was founded on a lack of science and something that was scientifically was disproven. There is no Mozart effect based on research. But you can kind of see if you study that whole phenomenon, you can kind of see how research went the wrong way. Okay, and how these bias, generalization, overconfidence got in the way of sound science. Because if you just followed and tracked the science, it was not reliable. Everybody was able to replicate it because they operationally defined it, but they weren't getting the same results. Okay. All right. And then make sure you spend some time on stats down there. Okay. So they're going to give you some type of statistics. Again, usually it's a scatter plot chart. It's a correlation coefficient. But again, the big thing we like in social science, or that we really want to look at, is variance, right? We like variance to be small. So whether it's my standard deviation, my range, I like data that is all close together, not spread out all over the place, okay? So that's why we use that measure of variance, okay? Statistical significance, okay? So make sure you look at that vocab term as well, all right? So you're gonna need to know that. So statistical significance, again, just tells me what is the chance that my results are impacted by chance, or are they actually based on the sound science and the method? So, if I find out that in my research that caffeine does impact sleep, okay, I'm going to have to also indicate and tell you, are those results impacted by chance some, or are they not? Okay, or are they really an impact of the research done? And the research, if it's really impacted by the research, then it's going to be more statistically significant, right? Okay, if it's impacted by chance, then it's not going to have high statistical significance. So statistical significance just means how much does chance impact my results. Okay, so remember we watched the video on the Mozart effect, and when people went back and looked at the original study, they said it lacked